Hi, this is Ryan, and this is my paper review number one. The paper I focused on was a paper I found called Sports Analytics for Football League Tables and Player Performance by Chazan Panzales and Tijorka. Just might have butchered those names. But basically, in this paper, they really wanted to focus on long-term predictions of both team performance and player performance in soccer leagues across Europe. For team performance specifically, they wanted to determine if they could predict better or worse seasons from the previous one, as well as match results and league table standings. For player performance, they focused on the central defender position and wanted to determine which key skills and statistics of that player best separate an average defender from an excellent defender. For the methodology for the team performance prediction, they took historical data from three seasons across 2015 and 2018. With this, each team had about 40 features that they used to determine and basically run through their models to determine if a team performed better or worse than the previous season. Um, Using those same 40 features, they also took statistical features such as expected goals and Pizzoli score, as well as financial data from the teams to further predict match results and standings of the end of season table across the European leagues. With this, they kind of ran it through a multitude of models just to see which ones had the best accuracy, such as random forest, SVM, naive bias, etc. Moving on to the player performance prediction methodology, wanted to focus on three different feature subsets. The first one being characteristics and attributes of the players, such as ratings, which could be speed, acceleration, that sort of thing. They also went on to focus on statistics of the players, such as defensive statistics, such as tackles, interceptions, as well as offensive statistics, such as pass accuracy, that sort of thing. Lastly, they also took and factored in team statistics because depending on which team a player may be on would drastically affect their performance since it is a team game. Um, with this, they started by building a multiple regression model using every attribute normalized and just seeing how that performed. Once they saw that performance wasn't the best on that, they worked to build kind of three separate regression models, kind of separating out each of these feature subsets and use backwards elimination to determine kind of the best features of each subset. With the results, the best accuracy for determining better or worse seasons was the random forest with the 70% accuracy. When trying to predict end of season league standings, they found SVM with a polykernel optimization performed the best with an RMSE of 9 points. Um, and with their model, they were able to predict the champions or overall winners of that table and standings correctly 64% of the time. Um, Moving on to player prediction, their best regression model had an R squared score of 0.907. They found that key predictors that attributed most to player performance were things such as interceptions, clearances, aerials won, and tackles. They also saw that offensive attributes contributed a large amount, such as passing or key passes and goals, as well as physical traits such as jumping, acceleration, and strength and affected a player's performance the most. After reading this paper, I guess for key takeaways, for the prediction specifically, they didn't account for things such as injuries or predicting draws. Focusing more on player prediction, which is more the route that I want to focus on for my capstone. Um, they found that the data set they used was relatively small since they only took 59 central defenders stats from one season, which could affect generalizability. They also saw that there was potential bias towards offensive stats, heavily influencing a player's performance or whatever metric was reported for that player's performance. as well as certain stats having high multicollinearity with each other, where um, high performance in passes could also showcase a high number in like their vision score, that sort of thing. Key takeaways I kind of found from this paper was the biggest thing was feature importance and how basically different features relate to each other. Where I could see things such as player statistics having high multicollinearity, which could kind of leads me down the road of potentially considering separating each features into a PCA, kind of creating subsets of groups of features just so to eliminate that potential in the data and the models. Um, Another thing to consider is contextual data, since that also impacted it, such as financial data of the teams, as well as focusing on high impact features. And kind of the biggest thing I kind of took away was the feature engineering of it all and making sure that the features I use kind of encapsulate relative or correlated features as well when predicting wide receiver statistics, etc. So, yeah, that was my paper review. Thanks for listening.